Okay, guys, let's get started with the lecture. Today I want to keep talking about tipping points. We started talking about tipping points during the last week, but then I also want to move on and talk about what we call thresholds or threshold models. But hopefully you'll see what we mean by that. So actually, we're going to do a little in-class experiment with this one as well. To see how threshold behavior actually works out. So let's see how that is going to fly. But before that, some announcements. First of all, let me announce on Friday, it's actually, you won't have the pleasure with me, but with Roland Adayani. So he's going to give a guest lecture on Friday. However, he's going to talk about exactly about what I would have talked about, and everything that he talks about is going to be relevant for the exam and for the assignment as well. So there's no difference here. But just that you are not surprised that there's another face going to be up front here. Right? So Roland, he knows exactly what the content is, and actually he uses exactly my material that I had prepared. And so he will talk about exactly the same thing. But so that you know. The other thing to talk about, we are approaching the time of the assignment. So the assignment is coming up, and originally I was about to put it up on Friday, on the 10th of March, but I decided, hey, why not just put it up there anyway? So it's already up. So you already see it on Blackboard. I put it up there this morning, but it's still going to be the same due date. Right, so my administrators talked to me and asked me, said that you guys have lots of other things to do, so now you have a little more time to do it, essentially. Yeah. So it's still due on the 24th of March. Late submissions, it's like a standard late submission, results in a loss of points. What you will see in the assignment is there are two sub-assignments, assignment 1 and assignment 2. You have to do both of them. There's no choice. Yeah. And at the end, I want you to prepare one document with headings for each of the sub-assignments, and I want you to submit this through Blackboard. There's no physical submission of this. So I don't want to see any of things in any inboxes. I don't check that kind of stuff anyway. Yeah? So I want to see, in physical boxes. This is through Blackboard only. Yeah? Through Blackboard, and well, it has a nice side effect that you guys actually type it on a computer or anything, and I can actually read it. I don't have to spend lots of time deciphering what you actually want to say. So prepare one document. In total, I want you to write about 1,500 words for this assignment, for both of these things together. In case there are any problems with the submission, get in touch with our undergraduate administrator, with Deirdre. She can help you on things. Any questions for the assignment, for this procedure, or how it's outlined?
How much is it worth?
Sorry?
How much is it worth?
How much is it worth? As outlined in the syllabus, it is 10% of your overall grade. And probably I'll give equal weight to both of these assignments that you have to do. Like the first sub-assignment, the second sub-assignment. I will also factor in style, grammar, so obviously these things matter. I haven't decided yet to which degree. Depends on how much that is an issue or not. Yeah, but obviously it pays to write this well. This is an exercise for the exam. At the end of the day, exam is not going to be too much different from these kind of things. Any other questions for the assignment? Yep.
I'm just looking at the assignment now here on the computer.
Yeah.
Both of these, the kind of two-part assignment,
Yep.
two kind of overarching ones, but each of them separated down
Yep.
further.
Yeah.
So for assignment 1, there's like subheadings 1 to 4,
Yes.
5 to 6.
Yeah,
for
yeah.
assignment 2. Can we treat them as separate questions in of themselves, or should we try and keep it kind of continuous?
If you want to treat them as separate questions, that actually makes my life easier. But at the end, whatever you feel like, yeah. So have a look at it, and the thing is, I don't know, maybe you haven't noticed this yet, but I value structure. I value structure in when you kind of give a coherent answer in a way. And one way of doing that is by actually structuring your paper, your response already. Yeah? So that's something which is, I think, generally good in life or in exams. Yeah. Any other questions about the assembly? Yep.
Is there a particular reference style you want us to use?
No. If you do reference, just at the end, well, the normal would be Harvard citation style, but to be honest, I don't really care. If you use APA, it's fine with me too. Yeah. But it's a good point. So if you do make references, please reference properly, right? So that's going to be also part of the grading. You know, if I see, I don't know, you're actually engaging with the material here in the correct way. If you make these references, you get points for it. Any other questions? Yep.
What do you mean around 1,500? Or does it have to be exactly 1,500?
Well, if you have 1,501, I won't kill you. Yeah. Maybe if you have 1,499, I might. That's basically what it means. Yeah. But that's actually a good point. So actually, what I'm giving you a mean. What you are asking for is a standard deviation. Standard deviation, you know, I think we did this last year. It's basically how much does this distribution spread around 1,500. Yeah. So I think I would like to see here. I would like to see you more at the upper end. So I don't know. Seriously, I don't know if it ends up 1,450. I don't know. I'm not going to count. Yeah. But aim for 1,500 in total. Okay, so let me move on now. They still haven't fixed this microphone. Seriously, this is kind of thing in weeks. Yeah. So this is still broken here, so I always have to lean to this side. Yeah. Anyway, so I want to talk about tipping points and thresholds. So we'll continue talking about tipping points. We started doing that the last time already. And remember, a tipping point is sort of like this thing where something seems to flip. Yeah. And we are coming back to that actually after the reading break. I have another lecture on broken windows where we will revisit the notion of a tipping point. In crime, it's a big one, where suddenly at some point, I don't know, a little more crime causes the whole thing to tip, and then it's hard to control anything anymore. Yeah? While people notice, okay, if you kind of crack on crime, even though it doesn't seem to have an impact, if you kind of come below a certain point, then suddenly crime seems to go magically away. Right? So it's this idea that sometimes things in society are not as linear, but sometimes they kind of tip. Yeah? And these things are big when you come from the natural sciences or in physics. There we talk about phase transitions a lot. Yeah? It's just like a change in state. Yeah? Like you cool something down, water is cold, but it's still liquid. But then at some point it freezes. Yeah? So very quickly it kind of changes. That's a tipping point, where you reach a point where something seems to then change dramatically. And why is that the case? Well, if you kind of think about how we talk about social influence and things like that, then you might understand that at some point, like the influence kind of seems to reinforce it, and then something takes off, while if influence is not there enough, then it doesn't reinforce it, and then it dies out. But I produced a few graphs along those lines to bring that point home. Basically, we often think that large effects are caused by something equally large. Yeah? But as soon as social influence comes into play, and I hope to convince you with that in this lecture, as soon as social influence comes to play, and a lot of life is about social influence, this does not have to be the case anymore. Yeah? Then kind of making a little more effort, and after the break, as I said, I will talk about the spread of violence or the spread of disobedience, yeah, and how small little changes can cause disorder to spread. But we'll come back to these kind of things. But along those lines, I have a first little exercise for you guys where I want you to think about something, and I want you to think about this notion of tipping. Yeah? Tipping happens in life all the time. Suddenly something becomes hugely successful, and sometimes for no apparent reason. Yeah? Think of an example for something that at some point all your friends suddenly started doing or using. Did you start doing or using it as well, and why? Yeah, so I give you 2 minutes, little groups, 2 or 3 or whatever, talk about that, and we will revisit. Yeah? Okay? Okay.
Yeah, so like usually who is trying to pass the range of
take an example where close to Okay, guys, let's continue. I talked with a few of you, I don't know, some things came up all the time, like, I don't know, social media, adoption of certain innovations. My friends are suddenly on WhatsApp, now I'm jumping on it too, and now suddenly everybody seems to be reachable there, right? And I remember back in the days, God, I'm old, when Facebook first came to Germany. Yeah? I remember the days before Facebook. And suddenly, at the beginning, nobody was on Facebook, and then within a very short amount of time, everybody seemed to be on Facebook. Yeah? And what happens here is, social influence plays an important role for these kind of things, or it can cause those things to tip, because if others already do it, then you have an incentive on it, right? So, and others can be reached in a certain way, then you have an incentive by, I don't know, using WhatsApp or Snapchat or Facebook or whatnot in a way. And by doing so, you actually amplify that, right? Because then other people, they have even more pressure to use it than themselves, right? And then, bang, right? In the same way, sometimes something just never kicks off. And the whole point that I'm trying to make here is that sometimes these differences are tiny between the thing that kicks off and the one that doesn't kick off, because social influence kind of takes over in the one but not in the other, right? So that's sort of some things that comes up. I was checking, actually, I was a little, last time I wanted to show you this video, so just for the fun of it, actually now I have it. Yeah. There's another thing. Yeah? Okay, we can watch one more and then. Okay, so that was a little bit about the Harlem Shake. Maybe you remember, but they are all, when you look around you, some people told me about dabbing. I don't know that, but apparently it's a certain move, right? And apparently it's hip right now. Right? I don't know it. I don't do it. But maybe I'm just uncool. Yeah. And so there are all these things that happen all the time. And when you kind of notice, there seem to be more and more of those kind of things, right? And actually, when we look back, I don't know, 20 years, 30 years back, try to ask your parents if they had something like the Harlem Shake, or if they had something like dabbing or whatnot. Yeah? Probably not to that degree. Probably not to that degree. And now you should be able to give me the answer for that. Why?
Social media.
Social media, connectedness, social influence. Yeah? Nowadays, you are so connected to other people, you actually see what other people are doing all the time. Right? So now we have those. They didn't have that, that Instagram feed from their neighbors to see what they are doing, and then they kind of jump on it, doing it in a way, right? So this actually tells us that these kind of things that I'm talking about, like tipping behavior, threshold models and things like that, they're becoming more and more important as we get more and more connected. Yeah. So that's sort of, I don't know, where you see social media playing a huge role, or just think about one of the assignments, or is it, I'm not sure. I think one of the exam questions last year I had was about social influence, where I asked students to think about examples of where social influence actually really matters or changes them in what they do. And once you start looking around it, you start seeing it everywhere. But anyway, so let me continue because I want to talk about some other stuff and I want to play yet another little experiment with you. So, this is just something that I already talked about. Sometimes things just take off, and a tipping point is sort of this dramatic moment when little causes drive the unexpected become highly to really advance, right? And the idea is that a small little change, if I do something a little below, it doesn't take off, but if I go a little further up, it does take off. How can that be? Well, think about it. Think about it in the case of the spread of a disease. Let's say we have a spread of a disease, and on average, 10 people when 10 people have the disease, they become healthy again, but let's say on average they infect 9 other people. What's going to happen at the end of the day? Well, 10 people infect 9, the first 10 become healthy again, then those 9, again, they infect 9 out of 10, so maybe they infect 8.1 on average, right? And then very quickly the whole thing dies out. While if instead of on average 10 people infecting 9 people, if it would be slightly a little more infectious, like 10 people would infect 11 people on average. You see, it's not a huge difference. But what would happen? I don't know, the next day, 11 people would be infected. The first 10 become healthy again, Then 11 people on average, they infect 11 out of 10. So they would infect then probably 12.1 or 2 or something on average. And then very quickly it goes up and it goes really, really high. So you see a small little change in the infection rate that I had here, a tiny little change, can decide whether there's going to be a pandemic or not. Yeah? Whether it really takes off. And this is sort of like a graph that I now put on this a little bit. Let's basically think of this on the x-axis. I plot time or steps, like 5, 10, 15, 20. This is basically times of, infection or whatnot, how you want to call it. And now I have a little function in here on the top. I say that the number depicted on the y-axis, this could be people adopting something or whatnot. Yeah? And here I'm just saying very simply that the number at a certain point s in time depends on how many people did it in the time before, s minus 1, multiplied with this infection rate that I have. Right? And now if I put x to 0.9 or x to 1.1, a small little difference, you see how it develops. Like in the one case it really takes off, and the other case it doesn't. And we can make this even more pronounced. So now I kind of set x to 0.99. And that's x3 and x4, I set it to 1.01. So you see there's a tiny little difference in the one thing being a little more infectious than the other. But that seems to really do something to the overall system. Yeah? At the end of the day, in the one case it really takes off. In the other case, it completely dies out. Right? So for all those kind of things that you do remember, suddenly a trend becomes hip, the Harlem Shake, the Ice Bucket Challenge or whatnot, or dabbing apparently. There are lots of other things that kind of were below that and it didn't take off. And it very quickly died out. And people wondered, that's just ridiculous. Yeah? Why are you doing this? So I guess the point that you get from this here is that you can have a tiny little difference. The difference from 0.99 to 1.01 is tiny, but it leads to those regime changes. In the one case, it completely takes off, and in the other case, it completely dies out. Okay, and oftentimes, people people studying diseases or public health, they are much more aware of these kind of things because they think about when are we going to have a pandemic? Yeah, and sometimes, maybe you remember, was it last year or 2 years ago when we had the Ebola crisis in Africa? Right? At first, they had like a few other cases, 20 or 30 cases, or maybe 100 cases, and they were all crazy about it. Why were they all crazy about it? Because they knew this thing can really multiply very quickly, right? So that's sort of why they really cracked it down, even when there are not that many, because it can completely take off. So sometimes it's actually crucially important, but in the social science we are not really good in thinking in these kind of terms. But hopefully, as you understood now, because of social media, because of social networks, because we are so connected with each other, these things become more and more relevant for us. Okay, but I want to move on and talk about thresholds. So we talked about tipping points, and now I want to talk about thresholds. What do we mean by thresholds? Well, thresholds basically goes back to a paper that this guy, Mark Grund, he's actually a big shot. Some people say one day he's going to win the Nobel Prize for sociology. He's a big shot in social network analysis, but he also did lots of other interesting things. So, for example, he wrote this paper in the 1970s, Threshold Models of Collective Behavior. So it's about modeling how do collectivities behave at the end of the day. And what do we mean by that? Well, we mean collectivities, people going on a protest march, for example, or a riot. And these kind of things, let's say there's a protest march, and in a second I'm going to play something like that with you. Let's say there's a protest march, we can think of these things as binary choices. Either you go onto the protest march or you don't, right? And the thing is, even if you have your doubts about whether you want to be there or not, by doing it, other people see, okay, well, there are people on this protest march, right? And now if you kind of apply that idea that then other people might be affected by it, then we are close to what we call threshold models. Threshold model is basically this idea, it captures this idea that sometimes individual behavior depends on the number of other individuals already engaging in that behavior. So I don't do anything, I don't do dabbing until, let's say, 50% of you guys do it, because then I know, okay, well, maybe I should up my moves. Yeah? So everybody is doing it, but before that I don't. But then when kind of that threshold is reached, then I jump on it. Yeah? That's this idea, you don't do it, and then you do it. Well, it only works for the binary behaviors in a certain way, but a lot of behavior is like that. Yeah? A lot of behavior is like that. And the classic example is that of people going on a strike or going on a protest move. So when other people strike, you actually, maybe if only a few other people go on a strike, you don't do it. But if lots of other people do it, then you do it. Right? So and there we're talking about individuals might have their threshold. When their threshold is reached, then they would engage in the behavior. Yeah? So that's this individual point. When you look at a preference function, it's like this, and then at a certain point it goes up. That's what we call the threshold function, and then it goes on. So, I don't know, some examples, even in education, if everybody in your cohort goes to the university, at some point you will go to the university too, because it changes the situation for you. Because then if you want to be competitive in the labor market afterwards, everybody else has a bloody degree, then you better have one too. Right? So there you actually see how these things can be affected by each other. But the classic example is that of a riot. Yeah? So, and Grund, he wrote in this paper about rioting a lot. And in the case of a riot, a threshold basically is the number of other people that would have to riot for somebody to join the riot. Yeah? Okay, so what we're going to do now we're going to play a little riot. Yeah. So I have a little example. So what's going to happen, I have this mug with pieces of paper in it. So I'm going to pass it around, and everybody just pick one piece of paper out of this. Right? It's just one piece of paper and pass on the mug. the round number is. So okay, so basically you see two numbers on this piece of paper. Right? Two numbers on this piece of paper. So this is now we're playing the riot. Basically, what does it mean? This number now represents, let's say this number represents, you're actually using two numbers. First, we're going to talk about as A and B. First, let's focus on the number A that you have for that. And this number is your threshold. Basically, it means that many people need to riot before you are going to riot. Yeah? Is that clear? It's a bit like, I don't know, I do something if 5 other people do it. Or I do something, I don't know, I might be inclined to give dabbing a try if 50 people in this room do it. Yeah? I have no idea. Yeah? But that would be my threshold. That would be my threshold. And oftentimes we have these thresholds. It's maybe not clearly formulated, but some people just do something. Some people just think, I don't care, I just do dabbing. Yeah? Who the fuck cares? Yeah, I'm just going to do it. Yeah? And so does everybody have a piece of paper? Yeah? Everybody has one? Are there any pieces left? How many are there left? 3. Okay, can you please pass them around so that some people have then 2 just at the top of you guys? Yeah? Because it's important that all of them are being used. Okay, so now everybody has at least 1, or some of you have 2, so that means like you have to play this twice. Is there anybody here who would riot if nobody else riots? Yeah? So your threshold is 0. Can you please stand up? So this is sort of the initial guy who riots. Yeah? He's just a rebel. Yeah? And if you look at him, he sits there in the front and everything. Yeah? He's just a rebel. Yeah? Yeah? Okay, can you show us please some dabbing? Okay. Okay, so now one person riots. So what happens? Does it do something to anybody of you? Yeah. Okay, what is your number? 1. So now this guy is rioting. Can you please stand up? So now you're rioting. 1. Anybody with 2? 2. Okay, now we have 3 people rioting. Who would have not rioted, but now the person starts rioting because there are 3 people rioting? We're looking at number A. Yeah. Seriously, guys, read. I made those figures. Somebody has number 3. Yeah. Somebody has number 3. Okay, so let me be it. I don't know. Because, so I'm rioting with number 3. Now we have 4 people standing up. 5. Okay. 6. 7. 8. 9. Okay. Well, 10. 11. 12. 13. Okay, so now 13 people are rioting. 14. 14. Seriously, guys. There are consecutive numbers. Please sit down. Everybody, please sit down. These numbers go down from 1 to 40. So basically the point here is that this would trigger the rioting of a whole cascade. At the end, all of you would be standing. Yeah? All of you would be standing. And that's sort of like the example that I have here. That's basically what I asked you to do. At the end, we have one rebel. It was our friend down here. He kind of did the dabbing. Yeah? And then, the next person would see, okay, now there's one person rioting, now I'm joining the riot. Yeah? And then the next person says, hang on, now I would not have done it before, but now there are enough people for me to join in as well. Yeah? And then the whole thing unfolds, and then you see what happens. At the end of the day, we have everybody rioting here. So in this case, if you guys would have read your numbers correctly, all of us would have stood up at the end of the day. So I gave you a second number. I'm not going to play that with you because we're running out of time. But in the second number, you have A and B. Who has the same number on A and B? Who doesn't? There's one person. Okay, what is your A and B?
My A is 5 and B is 6.
Okay. So what would have happened? if I would have played the same thing, imagining or assuming that we all understand how to read numbers and would have stood up and so on, yeah? If it would have reached 5, it would have stopped. Nothing would have happened because you would not have stood up because your second threshold would have been 6, right? But for everybody else, it would have been exactly the same. And that's, in a nutshell, what the paper of Mark Grund was about. It was about the distribution of thresholds. So now, you see the second examples here. Now I have it on 3 instead of on 5 or 6. So now in this case, there are 2 people that have a threshold of 3. What would happen in this case? Again, we have somebody who starts the riot. We have then somebody who follows, because now there's one person rioting, right? And then another person gets activated because of that. But then nothing happens after that. And then it dies off. And now I ask you, how different are these 2 scenarios from each other? For everybody, except for the gentleman here in the middle, the 2 thresholds were exactly the same. So we would have been in exactly the same world, with just a tiny, tiny little difference, but we would have had a huge implication. We would have had, in the first case, everybody standing up, while in the second case, we would have had only 5 people standing up. So that's basically the gist of this, the tiny differences in the threshold distribution, and that's what we call the distribution, how those things are distributed, how many people do have a threshold of a certain amount, that these differences, tiny differences, can lead to huge differences in the collective outcome. And there's more about this. I'm not going to talk about that, but if you're interested in that, the paper by Grund is a fascinating read. I keep going back to it, even though it's, over 40 years old now. It's a fascinating read, because he kind of figured that out at the time already, and how those changes he uses in a graphical solution and a mathematical solution to think about, okay, where do we converge at the end of the day? But the basic storyline is, at the end of the day, that when you have small little changes in how things are being distributed, this is like another change that you have. This is now a threshold distribution as well, and you would think they look exactly the same. So most of the people have a threshold around 25, but in the one case there are a little more standard deviation. We talk about standard deviation, and it's a little spread out. While in the other case, everybody's a little more closer, but it's a tiny little difference. If we would play it out, we would have a huge difference. At some point, it would kind of reach to, so this is now the standard deviation. If the standard deviation is below 12.5, almost nobody riots, while if it goes above 12.2, almost everybody starts rioting, because then you have these cascades picking up. So basically, that's sort of like the gist of the Grund paper. Grund showed that 2 threshold distributions that are almost exactly the same. In our case, they were almost exactly the same, except the gentleman here in the middle, and they can lead to completely different collective outcomes. What do we take out of this? Well, first of all, when something big happens, hopefully now you understand that this does not necessarily mean something dramatically different compared to when something small happens. It also means that every tiny little effort that you put in it really can matter, right? That it can actually, when social influence is there, and it is there more and more, that then things can really take off. Okay, so, I have other stuff about